is your challenge question that is given at the end of exercise 8B, where it is telling you that your f of x is equal to 1 by x. Okay, and you need to show that given that f dash x is equal to limit f of x plus h, that's given you the principle, and they're asking you to show f dash x is equal to this. So that means they're asking you to prove it through the principle. Since they're asking you to prove it through the principle, I know my f of x is nothing but 1 by x. So my f of x plus h will be nothing but 1 over x plus h. If I substitute these values in my definition of the derivative, what I will get is f dash x is equal to limit h tends to 0. In place of f of x plus h, I'm going to substitute. So I will be left with 1 over x plus h minus 1 over x, the whole divided by h. Okay, now I'm going to combine the factors in the numerator and the denominator. So what I am going to get is first on the side, I'm going to work out the numerator so it becomes easier for me. Okay, and for y'all also as well. So my numerator is 1 over x plus h minus 1 by x. When I am working this, okay, I need my denominator to be x plus h. So I already have the x plus h over here. I will multiply both the numerator and denominator by x. And I already have the x over here. So I'm going to multiply the numerator and denominator by x plus h. Okay, so this would become minus x plus h. So my numerator becomes x minus h divided by x plus h. So this x and x goes away. So my numerator is only minus h over x into x plus h. I substitute on the numerator this part. My numerator is minus h over x into x plus h, the whole thing divided by h. Okay, now I'm going to simplify by dividing by h on both the sides. So it's going to be limit h tends to 0. I'm going to divide by h. Okay, I will divide by h my numerator also and my denominator also. So if I'm dividing by h, the numerator and the denominator, this h and h will go away and h and h will go away. So I just divided by h. So I am left with minus 1 over x into x plus h. Okay, now I simplify the denominator. So I'm left with limit h tends to 0 minus 1 over x square plus xh. Okay, now I will deduce it. So limit h tends to 0, f dash x becomes minus 1 x square plus hx, and I have already proved this. Okay, now what I have to prove, I have done the A part. I've done my A part. Now my B part says deduce that f dash x is equal to minus 1 by x squared. So I say as h tends to 0, h is going to vanish. So my f dash x will be equal to minus 1 by x square, as this term is going to become 0, and thus I have proved my B part, that f dash x is equal to minus 1 over x square. With this I complete the entire section of exercise 8b.